So this is the second part of 6.5, and it's kites. We already did trapezoids, so we're just going to learn a little bit more specific stuff about kites. We'll learn 1, 2, 3 theorems. We'll do an example, and that will basically be it. Let's draw a kite. Let's not fly a kite. Let's draw a kite. So kind of looks like that. Oops. Something like that and that. That's close enough. Might not be exactly, but it's good enough for us. And they label it W, X, Y, and Z. That door's open. I'll have to lock it in a bit. All right, so here's the theorem. It's pretty basic. At least this one is. Let's not do the theorem just yet. Let's go back to the definition of a kite. Do you remember what the definition of a kite was? It's got two, I forget exactly the words, but the two consecutive sides are what? Are congruent to. It's got exactly two pairs of consecutive sides congruent, all right? But remember, the sides that are opposite each other are the ones that are not congruent, so you can't say that, all right? So this one, so WX, by definition, if I told you this was a kite, so I'm given, we don't have any kind of like symbol for kite, so I just write the word kite in front of it, all right? So I just write kite, what would you call it? W what? X, Y, Z, all right? So I'm given that it's a kite. So what do I know about it right now? If I told you this was a kite for sure, what could you tell me about WX? Yep, it's congruent to WZ. And then what's true about XY? It's equal to ZY, right? Everybody got that? That's by definition, okay? If they told us that this was a kite, then that would be true. That's the only thing we know so far about this. Would you agree? I'll tell you what, let's do the proof. The proof is really simple. So what I'm going to do is I'm going to draw a line that connects from here to here. And I just want to take a look at it. I got two triangles now, don't I? Yeah. Go. I've got two triangles, right? I've got a side, and what else do I have? What's that? I got another side. I got a third side, right? I got a side. I'm trying to lead you in this direction, okay? I'm trying to make this easy. I'm trying to lead you along, holding your hand. Watch. I got a side, and I got a side. You see that? Because this side is shared by both of those triangles. Agreed? So what do we know about these two triangles then? I got a side, and a side. Come on, it hasn't been that long. What do I know about those two triangles? They're congruent to each other, right? Those triangles are congruent to each other. Everybody understand that? If they're congruent to each other, if I was to take those and fold them on top of each other, everything would match up. The corresponding parts would be equal to each other. Would you agree? So let's mark some things. What do I know about X and Z then? If these triangles are congruent to each other, what do I know about X and Z? They're equal to each other. That's right. They're congruent because they're corresponding parts of those congruent triangles. Do you remember that? C, P, C, T, C. Corresponding parts of congruent triangles are what? Congruent. All right? These are congruent triangles. These correspond to each other because if I took this and I folded it, right, so that everything matches up, then what would match up? Then this angle and this angle would be equal to each other. Agreed? Yes? All right. So you could also say that this little angle right here and this little angle right here would be equal. This one here and this one here would be equal. That would be true. What would also be, that brings us to another theorem we're going to do in a second. All right. So that's good right there. So what does our theorem say? We just proved this theorem. The theorem says that exactly one pair of opposite angles, I'll just shorten opposite and angles, in a kite are what? Congruent or equal. I don't care if you say equal. It says exactly one pair of opposite angles, which means what? Which means that W and Y are what? Does it mean they're equal? We've already established that this one and this one are equal, right? Because of congruent triangles. So it says exactly one pair of opposite angles of a kite are equal to each other. So what does that mean about this big angle W and this big angle Y? Are you serious? Didn't we just have one? Oh my word. All right. Fire drill. Let's pause. No. Okay, now it's recording again. All right, we finished our exciting fire drill, so let's continue. Whoops. All right, here we go. All right, so what does this theorem say? It says exactly one pair of opposite sides are equal. So let's go back to this. Everybody looked like completely stunned. It's not that hard. It says exactly one pair of opposite sides of a kite are equal to each other. So what's true about this big angle W and this big angle Y? Are they equal to each other? No, they're not. That's all I was trying to get at, okay? Is that they are not equal to each other because these are equal to each other right here. You see that? Because this is part of this triangle. This is part of that triangle. Look at this. Look at this big whole angle right there. Is that part of this triangle? No. It's more than that triangle. This is more than that triangle. Agreed? Yes? Okay. So let's talk about something else. This is another theorem. We might as well just get to it. Yeah, we'll just kind of lean into it a little bit here. So, or lead into it. Come on. Let's do yellow. All right. So tell me something about this. Remember, this top triangle is congruent to this bottom triangle. So that means that X and Z are equal to each other. Agreed? All right. So I'm going to put some numbers in here. 1, 2, 3, and 4. So tell me something else that you know are equal to each other. I just made it easy so you don't have to. Yeah, 1 and 2 would be equal to each other, right? Because if I fold those triangles and made them sit right on top of each other, 1 and 2 would match up, wouldn't they? They're the corresponding angles. So that means that 1 and 2 would equal each other. What do we know about 3 and 4? They would equal each other as well. Does that mean that 1 and 3 are equal, though? No, it doesn't. Okay, but 1 and 2 are equal. 3 and 4 are equal because of what? Corresponding parts of congruent triangles are congruent to each other. Okay, we're going to talk about that in a second. I figured since I had this picture up here already that we would just discuss it right now. All right, let's draw another kite, and let's do. They call this that diagonal that we drew. We could also draw another diagonal, couldn't we? So again, let's draw a kite. I should already have one of these drawn and then just copy and paste it, but did you fly a kite? I did. Didn't we have that talk when we first talked about kites? Oh yeah, you did. Remember on the bus at church, they would give out free kites to everybody? Yeah. All right, let's draw the diagonals. Let's do this in a different color then, since we're going to talk about specifically the diagonals. And let's do this. Let's just make this a little bit bigger, just so we can see it a little bit better. All right, one more time. Let's try this, change the color of it. And I'm going to draw the diagonals. So let's draw all the diagonals I can draw. So that's one diagonal I can draw. Can I draw another diagonal? Yeah, from here to here. Okay. Now, if I drew this kite, I might be off just slightly, half a degree maybe or something like that, but it's pretty close. It looks pretty close. What does it look like? What's your gut instinct is true about those? Yeah, they look definitely like they hit each other at a right angle, and that's absolutely true. All right, that they are perpendicular to each other. Okay, that's our second theorem. So our first theorem says that it's got exactly one pair of opposite angles equal to each other. The second theorem says that the diagonals are perpendicular to each other. So that means we have what kind of triangles? What kind of triangle is this triangle right here? And this one right here? And this one right here? What are they? Right triangles. Okay, very good. Okay, so we've learned a couple things about right triangles before, right? Pythagorean theorem, different things like that. So yeah, that helps us out a little bit. If they give us some missing sides, right, you want to find another side. Like if they give me this side right here, this little segment here, this little segment here, I could do Pythagorean theorem to find this one, right, or whatever. Everybody got that? All right, now here's something else they say. It says they throw this word in, the axis of symmetry. Let me put some letters. I'll tell you what I'm going to do on this one though. I don't really have to do this, but this is how it looks in the book. It's how I put it in my notes. Let's make that a little smaller so it fits. There we go. All right, that looks a little bit better. All right, so let's label this the way the book does. I want yellow, I want white. All right, so I'm going to call this oh, look how fancy they got. Look what they labeled it as. Kite, right? K-I-T-E. And then they put an X in the middle. All right? So what do we know so far? That second theorem, what do we know? We know that KT would be what? Perpendicular to, very good, IE. All right? So they would be perpendicular to each other. So that's one thing we know. So let's write that. So KT, I'm going to put a little line segment over top of it because I'm not talking about the measure of it. I'm talking about the line segment itself, okay? So line segment KT is perpendicular to line segment IE. All right, so we know that from our second theorem. Here's the third theorem, and we know two things. We actually kind of alluded to it on the other one, but we'll say it right here. They call IE, this IE right here, they call the axis of symmetry. That's a word when you get into Algebra 2, you're going to hear quite a bit, all right? So the axis of symmetry, it just means it's a line that divides it basically symmetrically, right? So it's the same on one side as it is on the other side. Would KT be an axis of symmetry? No, because look, if KT doesn't divide it, like this part, this triangle right here and this triangle down here, definitely not equal to each other, agreed? On a kite. But this would be my axis of symmetry because it divides it so it's symmetric. You ever hear that word, symmetric? It means it's the same on one side as it is on the other side. There's symmetry to it. All right, so they call this the axis of symmetry, and they call KT, they call this the crossbar. KT, they consider the crossbar. So, with that said, the theorem says this. It says the axis of symmetry bisects the crossbar. So let's stop right there because they give you a second part of it too. But let's stop right there. The axis of symmetry, which is IE, so let's write IE, bisects the crossbar. Which one's the crossbar? KT. So what does that mean? What could I write underneath of this about some line segments, some lengths of line segments? I could say that KX is what? Equal to what? XT. Well, let's put TX. We'll put X in the middle. Everybody see that? Or congruent. Equal, congruent. It's fine. Everybody with me on that? So when you have two diagonals in a kite, that means this one and this one are equal to each other. What about IX and EX? Are they equal to each other? No. It's just the crossbar, okay? Just the crossbar is being bisected. They don't bisect each other. Remember we did rhombus. We said the diagonals bisect each other. That's not happening here, all right? It just bisects the crossbar. And then basically what we said earlier, and I'm going to put those numbers in here again. This is where they officially say that thing that we did before, okay? So what is true about angle 1 and 2? They're equal to each other, agreed? All right? And then 3 and 4 are equal to each other. I'll just put one arc. Remember that? Okay, because they're congruent triangles. I'm going to read off the way that they say it in the theorem. It says that the two non-congruent angles, remember, these are the congruent angles right here, aren't they? So the two non-congruent angles, that'd be angle I and angle E, the big angle I and the big angle E. It says are being bisected by that axis of symmetry as well. So the axis of symmetry bisects two things. It bisects the crossbar, and it bisects what else? The two non-congruent angles. That's what the theorem says. If you look in the book, it's pretty much word for word. You okay with that? So the axis of symmetry bisects the crossbar, which means this and this are equal to each other, and it also bisects the non-congruent angles, right? These are my congruent angles right here, and these are my non-congruent angles. This big old angle right here and this big old angle down here, they're the non-congruent, but that axis of symmetry bisects those two non-congruent angles. So there's a lot of stuff to keep straight, isn't there? Okay, on all the different things about a trapezoid and the diagonals and the opposite angles and all that kind of stuff, the opposite sides, right? The non-consecutive sides, right? Depending on which one you're talking about. So there's a lot of information to remember, but once you remember it, it's not hard to do the math part of it. It's really not. So let's do, yeah, we got time. We got 10 minutes. So let's see what I can do. Would it be easier just drawing another kite? Probably would. I was just going to get rid of all that stuff there. Might just be easier to just draw another kite. All right, that's good enough. And then draw a diagonal. Oh, I didn't draw that very accurately. It's off a little bit, but that's okay. It's definitely not perfect, but it'll work. We're going to use the same letters. All right, so they tell you that this is a kite. So they say kite. Now it's kind of weird if you start with K, it'd be what? K-I-T-E. Do you have to start at K though? No, I could have started at T. I could have called it T-I-K-E. Or I could have called it T-E-K-I, right? It doesn't matter. But they call it this. All right, so that's what they tell you. They tell you this is a kite. So what do you know about this since it's a kite? Well, let's mark a few things that we know without even putting any stuff in that they tell you. Okay, let's just mark some stuff that they know, that we know. We know that this side's equal to this side. We know that this one's equal to this one. We know that that little bit and that little bit are equal. We know this big angle K is equal to this big angle T, right? So there's a whole bunch of stuff we know. We know these two angles right here are equal to each other. We know these two angles up here are equal to each other, all right? I think that's pretty much everything we know about this. So let's see what they give us. They give us, again, this is all given. It's given. That's how they say this in geometry. When they tell you what's equal to stuff on this picture, they say this is all the stuff that's given to you. So they tell you that angle XKE, let's make that a K first, then an E, is 55 degrees. XKE, yeah, there's X. Yep. And is 55 degrees. And all right, this is kind of weird, but they tell you that KI, line segment KI, is less than line segment KE. All right, and you got to find, they ask you to find 5 different things. So let's write them down over here. So you want to find part A, you want to find angle KTE. Then you want to find TXE, angle TXE. Then you want to find angle KEX, oops, forgot the angle symbol. Let's put that right there. KEX. Then you want to find angle KET. Well, let me just write all these down before I start thinking about solving this. So KIE. All right. Okay, here we go. Let's change colors. All this black and white. Too boring. All right. KTE, where is that? KTE, that's this one right here. Well, let's put what we know first, okay? XKE, what's XKE? Let's do this in white. Where's X? XKE is 55, so that's 55 degrees right there, okay? So now, what do you think that green angle is right there? It's also 55, exactly right, because these two, you know, are equal to each other because it's being bisected. You know these two are 90 degrees, right? So that means that this has to be equal to this, all right? I'm not going to give any more explanation than that. So that would also be 55. Also, these triangles right here are congruent triangles, right? If you look at XE, it's equal on both of them, right? So these are congruent because of side, side, side. So these are corresponding parts. So that's 55. All right, TXE, where's that? TXE, oh, that's easy. What's that one? Right where the X is. Yeah, it's 90 degrees, okay, because it's perpendicular, so that's 90 degrees. All right, and KEX. KEX, that's this little one. Let's do it in a different color now. That's this little one right there. Now, how do we find that? Because they don't even tell you what that big angle. If they told you that whole big angle E, then I could just split it in half and get that, couldn't I? But they don't. But you do have a triangle here. And you don't have any triangle. You have a what kind of a triangle? You have a right triangle. So what would I do to get that third? Yeah, it's 90 minus 55. And what's that? 35? All right, so that angle is 35 degrees. Okay? Change colors again. All right, what's the next one? KET. KET. Oh, that's easy. We're finding that big angle right there. Well, remember, it's being bisected, right, by that axis of symmetry line. So if that's 35, what's this little skinny angle right here? It's also 35, but that's not what they're asking for. What are they asking for? That whole big thing. So what do I do? Just add them up. So 35 plus 35, that's 70. So that's 70. Now, here's the one that's a little bit weird. Do you see what they gave you right here? They say that KI, this one right here, is bigger than KE. Now, it sure doesn't look, oh no, it's less than. Okay, now it does look like it, okay? So this one right here is less than this one right here. Okay? So, let me think. We want to find KIE. KIE, this one right here. It's not equal to 35, right? Because these two angles aren't the same. I'm stumped. I shouldn't be. Remember we did those inequality things? We did like side, side, side inequality, side angle, side inequality, and all that. I'm sure that's what we're going to use here. I'm just trying to see how it's being used. So I have this one is less than this one. So the angle opposite, let's see. XKI? We don't know. We don't know, and I don't think we can figure that out. Well, no, don't think we can. Well, I should know this. It's just, I mean, I see the answer in front of me. Just trying to give a good explanation of it. Go ahead. I can't. You guys speak up. I can't hear. Right. I'll tell you right now. I'll give you a hint. You're exactly right. You can't get just one answer for it. Since they say that this is less than this, I want to find some range. I want to find some range that this angle has to be. It has to be between something and something else. Okay, well, it is part of a right triangle, isn't it? Okay, so it has to be less than what? 90. Agreed? Right? And it has to do something with this right here. So this right here, this is opposite the 90, so that's the biggest side. This is opposite, this is opposite this side. Oh, my bad on this. I'm gonna have to look at it and then come back to you tomorrow about that. But I'll give you the answer. Okay, it says that angle KIE, angle KIE is between. This is how we do between. So it's got to be greater than 35 degrees, and it has to be less than 90 degrees. I understand why it has to be less than 90 degrees, don't you? Because both of these angles right here have to be less than 90, because on a 90 degree, on a right triangle, 90 is always the biggest angle. Agreed? So this has to be less than that. Right here, let's take a look at this. This also has to be less than 90. Oh. I just can't get a good explanation for it. I see it, but I just can't verbally give you a good explanation for it. I'll work on that, and I'll try to give that to you tomorrow. I'm sure you won't really care that much, but it bothers me that I can't see that. And I'm sure I saw it last year because I just wrote down the answer, and so I know I just looked at it. It's probably a very simple thing, but I just have to, I got to figure it out. So there you go. My bad on that. Sorry. Hope I didn't let you down. All right. So we have some homework, right? So what are we going up to now? What is it up to? 25 or something like that? Or 18 to 25? Okay. And you have a few from the other one that had some kites on it, right? So basically, is it 1? Did the other one start at 1? Okay, so we're basically doing 1 to 25. You okay with that? Let's just make it one assignment, okay? Because there's a little bleed over of that kite stuff to that first assignment I gave you. So let's just do 1 to 25 on section, what is this, 6 what? 5? 6.5? Okay. So it's section 6.5. Let's go all the way up to 25. Whatever you didn't do last night, just continue it up to 25. Everybody good? Okay.